Portal and its hugely popular sequel, Portal 2, are video games that take place in a future dystopia, inside a massive complex known as Aperture Science, run by a comically evil robotic master, GLaDOS. The main character, Chell, trapped within this complex as a test subject, is equipped with nothing but a gun that can create instantaneous portals between two places and a pair of impact-absorbing boots. She creates portals by firing the gun first at a wall, floor, or ceiling coated with a moon dust-derived material, and then at another similarly coated place. She can then step through and travel from one place to another. At a recent reveal of the new handheld Steam Deck mobile gaming system, a Portal-themed version was demoed, fat chance obtaining one as it is only a prototype, showing that Portal is still near and dear to Maker Valve Software even 10 years since the last game. The game doesn't quite explain the physics of the Portal gun. It claims it was developed in the 1950s as the Aperture Science portable quantum tunneling device. This suggests that it works via quantum principles rather than creating a wormhole through space and time as in Star Trek or Stargate. A wormhole would of course not appear as a two-dimensional portal anyway. A perennial pet peeve of mine comes from watching sci-fi depicting wormholes as train tunnels. Its entrances would each be a 3D sphere like this one. A wormhole could certainly get the job done, transporting Chell from one place to another. Because it is a 4D tunnel with 3D openings, however, she would not simply pass into one and emerge from the other with the same direction and speed. Instead, it would be more like entering an orbit around a planet, called a geodesic, inside the tunnel, and she would emerge at a very particular location, given where and how she entered. You can see this in the picture above, where the light rays from the other side are bent. Her path would likewise be bent, so she would be flung out in a particular direction. Thankfully, by invoking quantum tunneling, the creators of the game avoided all these details. Quantum tunneling is a process by which a particle can overcome a barrier by the principle of quantum uncertainty. It works like this. A particle is in a delocalized state given by a wave called a wave function, such that its highest probability location is on one side of a barrier. As it heads towards the barrier and impacts it, the bulk of its wave function rebounds off of it, but a significant portion of it passes through. This is similar to a coated mirror that allows light through with some probability. No surface is 100% impenetrable. When a measurement is made of the particle, there is a significant probability of finding it on the other side of the barrier, at which point the wave function on the initial side, left side in the animation, vanishes. Thus, it has really transferred from one side to the other. Assuming you could tunnel through barriers with your wave-like nature, hardly likely for macroscopic objects like Chell, a quantum tunneling gun would appear to make it easier to pass through walls, but not create portals between distant points. Moreover, with tunneling, you are still more likely to rebound off the wall than pass through. It would take a number of attempts before the statistical likelihood would allow it. You might think that quantum teleportation is a more likely candidate here, but teleportation involves transferring the quantum properties of a particle to another one, using an entangled intermediate. That doesn't seem to be what is happening here. Delocalization has other consequences besides tunneling. For example, the Aharonov-Bohm effect occurs when a particle such as an electron is affected by a distant magnetic or electric field. This is similar to tunneling, but the particle is not impacting a barrier. Rather, it is experiencing effects that are outside the confined space it is in. This has been demonstrated in the lab, even when the electric or magnetic field is segregated from the particle's apparent trajectory by insulation. This effect, however, typically changes the phase of the wave function, which you can see as the rotation angle of the green wave in the animation above, and not the amplitude, which is the height, the likelihood of finding it in a particular location. So, something like Aharonov-Bohm isn't going on either. So, how would you achieve the portal gun effect? Let's ignore the fact that we are talking about macroscopic objects and imagine if a quantum particle, that we will call a Chell, could, theoretically, experience what Chell experiences in Portal. Tunneling is still the most likely effect here, but we need to determine how the wave function can pass into one portal and emerge from another as if they are on two sides of a wall. Let's assume that the passage through the portal does not violate relativity, and that passage takes some small amount of time with speed below the speed of light. It isn't clear from the game whether it does or not, but it must be pretty close to light speed. Experiments make it clear that tunneling is not instantaneous. We could theoretically achieve the effect using quantum tunneling and some mirrors, lenses, or force fields. If we were to place mirrors or lenses at the two walls and point them so as to reflect or refract the Chell from the entrance portal to the exit portal, then the particle could tunnel through any barriers in between and emerge at the desired location. If the Chell were a charged particle like an electron, a magnetic field would do the same job even more easily. This means that the quantum tunneling taking place is not through the walls onto which the portals are projected, but through the walls between the portal locations. The portals must delocalize particles, accelerate them to a high velocity, and then act like mirrors or lenses to alter the trajectory of delocalized particles. This fits with the portals being two-dimensional. They reflect or refract the Chell from one portal towards the other, like this. That was all for today. Hope you enjoyed the video. Like, subscribe, and good night.